Hello everyone, welcome to the course Data Structures. This is Thulasi Chitra, Associate Professor, Department of CSIT, MLR Institute of Technology. In today's overview, we will be discussing about circular single linked list insertion operations. Let us see under this overview what are the topics we are going to discuss. Here we will be seeing about circular single linked list insertion operations. Under these insertion operations, we have 4 different categories. As we have already discussed in the single linked list and double linked list, in the same way we are going to discuss regarding the circular single linked list insertion operations. Here we come across 4 different operations, that is inserting a new node at the beginning of the list. The other one is inserting a new node at the end of the list. And the third one is inserting a new node after the given element, and the last one we have is inserting a new node before the given element. These 4 cases we have already seen in the single linked list as well as in the double linked list. How it is differentiated in the circular single linked list we are going to see now. And with this we will be seeing about the implementation part of circular single linked list with all these insertion operations. Okay, let us see the first case we have. Consider this is a list with 3 nodes, and here it is representing a circular representation, circular single linked list representation, where the last node address is going to be stored with the head address. Right, that is why we are storing 1000 here. Once check the previous video what we have discussed regarding circular single linked list, so that you will be knowing how to create and display all the elements in the circular single linked list. Right, now I want to insert a new node at the beginning of the list. That means the same procedure, we need to allocate the memory, reading the data part and assigning address to it. Right, and this is the same procedure where we have followed in the single linked list also. Right, the same thing, look at here, and here it is a memory allocation, and this is the data value, and the address part we have assigned to null, and the name of this node is n and it is 5000, the address we have assumed it as 5000. Now make the link between these two. Right, and when you are representing this link, it will be storing the address of 1000 into this location, that is into null. Okay, now we are removing this head and we are assigning this head to the node which we have inserted newly. Okay, now after making the head as this one, at the same time we need to remove this link and we need to assign this link to the head also. So that what we are going to do, we are going to remove this link and making the link from the last to head. At the same time, we need to store that address also into this location. That means instead of previous it was 1000, now it is updated with 5000. Yes. Now how we are going to write the code here? Let us see. These are the steps where we are going to use for allocating the memory and reading the data part. And this one, n arrow next equal to head, represents where it is going to make the connection from the node which we have created and already existing head node. Right, and head equal to n, what are the new node you have created, this becomes the head node, and at last we are going to store the address of last node. You have this one, right, this is the last node which we have represented. Here previously it is 1000, now we are going to store with 5000, the new node address we are going to store, so that it will make the link like this. This is inserting a node at the beginning of the list. Next, coming to the inserting a node at the end of the list. Now same, we are going to consider the 3 nodes where we are going to have the head and last nodes, and we are going to make the links between all the nodes and considering the addresses, and this is a circular single linked list. Now I want to insert a new node at the end of the list. That means here I want to insert a new node. In this case, how we are going to do? Again same, allocating the memory to it and reading the data value, and address part is null, and assigning address as 1000 and the name of this node is n. Now make the link between these two. Here now I am adding at the end of it, so that last arrow next equal to n. That means we are going to store the 4000 address at this place, and at the same time we are going to remove the last value and assigning this to the node which we have inserted newly. Now make the link from the last node to the head node. That means we are going to store the 1000 here address, and we are removing the link from here and making the link from the last node to this, so that we are storing the address of 1000 here. This is the second case. Now see the logic how we are going to write. Allocating the memory, reading the data value and assigning next part to null. We have seen where we are going to have 40 and null is created, and the name of this one is n, and 4000 we have created. Now previously we have the last node here, we are making the link between this, right? That's why when you are going to have a link between this, previously this is 1000, right? Now in this we are going to store the address as 4000. For that we are going to write the step last arrow next equal to n, and at the same time we are going to remove this as the last node and we make this as the last node, so that we are going to assign last equal to n. And not only that, the last node which we have created newly, that should be assigned to head, right? So that we are going to write last arrow next equal to head. Okay, this is a case where we can do the insertion at the end. And we have the third case, inserting a new node after the given element. And this will be similarly like our single linked list. Here in the circular single linked list, you will be finding more difference in the insertion at the begin and insertion at the end. The remaining part of that is insertion after the given element or insertion before the given element will be the same what we have performed in the single linked list, but the loop representation may differ. Okay, let us see what we are going to do in that. Here we are going to consider the 4 nodes. The first node represents the head and the last node represents the last. Now I want to insert a new node after a given element. The same procedure we are going to follow. Suppose consider I want to insert the element based on my key value 20. After 20 I want to insert a new node. Now I need to traverse through the list, and whether the 20 is present in the list or not, we are going to verify. If it reaches 20, we are going to stop, and then we are going to insert the new node into it, right? Now start doing this, and here we are going to allocate the memory by malloc function, allocated memory, reading the data part, and initially it will be null, right? And the address of this one we are going to take it as n, and its address is 5000. This can be done later also, right? First I have done this one. Now I am going to search for the key element. Now before that, before searching the key element, we are going to assign our temp equal to head value, right? Now start traversing through the list, so that here first we are going to check our temp arrow data equal to the key value or not. We are going to check temp arrow data equal to key. Here temp arrow data is 10, 10 equal to key value is 20. It is not true. So that we are going to move our temp value to the next location. Now, yes, temp arrow is 20 and 20 equal to 20. Yes, key value it reached. Now we are going to make the connections. How we are going to make the connections? First, we are going to make the right connection, and then we are going to make the left connection. When we are going to make the right connection, here observe what we are going to do. We are going to store the address of 3000 into this location, and we are storing the 5000 address into this location, and we need to know the names of this one. To know the names of it, you can refer the previous video for much more clarity. And here this is temp, and this is n, and this is nothing but the temp arrow next node. Temp arrow next. Based on this, we are going to make the connections. Okay, and it will be the same. Here we are not doing any changes. The link will be the same, right? Now let us see here once. Let us see the code how we are going to write. Here we will be allocating the memory, this part, reading the key value, and we are going to assign temp equal to head. But when you are going to compare this one with the single linked list, there we have started while loop, and we are going to check until temp value not equal to null. Why? Because in the single linked list we have the null pointer, but here in the circular single linked list we don't find the null pointer, right? That's why we are unable to check this condition. We are going to use another loop that is called do while loop. Why? Because if I am going to check temp not equal to head, this condition fails at the starting itself. That's why we are going for the do while loop. First the statement will be executed, then the condition will be checked in this, right? So that we are going to start using the do while loop, right? And here temp arrow data equal to key. We have seen that it is reaching 20, and if it reaches with the key value, then we are going to terminate the loop and we are going to make the connections. And for the connections, once you can check for the single linked list representation. N arrow next equal to temp arrow next, and temp arrow next equal to n. These are the cases we have already discussed. And if the key value is not present, then you need to move your temp to the next location until when it has to be repeated, until it reaches temp not equal to head. In the circular linked list, if it reaches the head value, then it is going to terminate, the loop will be terminated, right? So that we are going to use the do while loop in the circular single linked list. This one please remember. Okay, in a single linked list and normal double linked list we are going to use while loop, but here we are going to use do while loop because you don't find the null pointer in this to traverse through the list. Here you need to traverse through the list until you reaches temp not equal to head. That's why we are going to use this particular loop statement. Okay, and this is for insertion after a given node. At the same time, we will look into the insertion before the given node, right? This will be similarly like the single linked list as we have discussed. Here instead of while loop, we are going to use do while loop. The remaining part will be the same. We are taking one more extra variable to know the names of it. Okay, let us see. Here we are going to have the head and last part as the first and last nodes which are representing, and allocating the data value by using malloc function, the same procedure. And instead of this, what we are going to do is, we are going to take one more pointer variable when I am moving my temp to the next location. Okay, let us see. Temp is moving to the next location, right? Temp is moving to the next location, we are assigning temp to the previous value. Before that, what we are going to do is, we are going to check our temp arrow data equal to key value or not. The same thing what we did it in the previous case, right? Here temp arrow data is 10 equal to the key value. Key value I consider I am taking it as 30. Before element I want to insert, right? That's why I am taking the key value as 30. Before 30 I need to insert the new node. Now 10 is not equal to 30, so that we are moving our temp to the next location. That means we are going to write the statement temp equal to temp arrow next. This has to be done, right? Now again you are going to check your temp arrow data value. Now what is your temp arrow data? Now it is 20. Is 20 equal to 30? Again no. Now again move your temp value to the next location. Before moving temp to the next location, you need to make this one as P1, and now this is not your P1, right? Now your temp is pointing to this location. Now this is 30, yes, 30 equal to 30. It reaches the key value. Now you are going to stop. Now identify the names here. This is P1, this is N, and this is temp. These are the three names. Now make the connections for it. First you need to make the right connection and then followed by the left connection. Now how to make the right connection? What is the statement we need to write? Right? I need to store the address of 3000 here. Previously it was null. Now we need to store it with 3000. Now N arrow, this is nothing but the right. N arrow next equal to temp we are going to store. And this one, here we need to store the address of 5000, that is nothing but P1 arrow next equal to N we are going to store. These are the two steps to be included, right? Let us see the code. At the same time we need to represent the circular linked list representation also. Let us see the code how we are going to write. These 3 steps are required for allocating the memory, reading the data value and assigning next to null, and reading the key value and temp will be assigned to head. As I said, we are going to use do while loop here, right? Why I am not using while loop, I said previously. If I am going to use while loop, at the starting itself the condition will be failed, temp not equal to head. Temp is assigned to head and temp value is 1000 and head value is also 1000, right? 1000 not equal to 1000, here itself the condition fails. It will not enter into the loop. That's why we are going to use the do while loop here, right? And if you are going to check temp arrow data equal to key, if it reaches, if you are having the key value, then it will terminate and it will be making the connection with the new node which you have created, right? If not, you are going to assign temp to P1 and temp will be moved to the next location, right? This is the one which we are going to perform in insertion before. Let us see the implementation part of it and open our online C compiler GDB. I will be showing you how we need to execute all these cases in online C compiler. I have written already program. Let us run this program and check whether it is working properly or not, right? First case, first try to insert all the four nodes into the linker list. Choice 1, choice 1 again, 30, choice 1, 40. Right. Now, to try to display all the elements by using the key menu operation as 2, right. Now, it is displaying all 10, 20, 30 and 40. You have 4 nodes here, right. Now, perform a third operation, enter choice 3, enter the data value. The data value I want to insert at the beginning, right. Data value is 5. Now, try to display it whether it is inserting at the beginning of the list. Yes, it is inserting. Next, choice as 4. Now, you need to read the data value here. I have missed that statement. Data value, you take it as some 50. Now, try to display it. Yes, now you can see here 50 is displaying at the end of the list. Here you can see into this, right? And choice 4 is completed, right? Choice 5. In choice 5, again you need to read the data value. What is the data value? Suppose I want to insert 25. Key value to be, after which key value I need to insert. Suppose I want to insert after 20. Try to display it. Yes, after 20 we can able to insert 25, right. Next, choice 6, read the data value again. Suppose I want to insert 28, before which element I want to insert. Suppose consider 30 I want to insert and perform display operation. Yes, before 30 I have inserted 28, right. This is how where we can perform the insertion operations, right. Once you can try this logic, I have given all the operations separately, just you can represent in a single program and you can execute this, right. And coming to the last one, summary of this session, where we have discussed about all the circular single linker list insertion operations. We have discussed about inserting a new node at the beginning of the list, then inserting a new node at the end of the list, and inserting a new node after the given element, and the last one inserting a new node before the given element. With this I have shown you the implementation part also, right. We have seen the implementation of this circular single linker list insertion operations. And while executing your program, if you are having any errors or anything has been raised, please do it in the comment section. Thank you.